So before we can try out the whole solution, we navigate to GitHub, to my account chgeuer x Microsoft ARM evaluator, and in the README we can see how to install or from where to install Elixir, and on top of Elixir we need to install Erlang. So in the Erlang download section for Windows, for example, we see the 64-bit binary which we can download, and in the Windows download section on Elixir, we have the web installer for Elixir. So once these two bits and pieces are installed, downloaded, we have the installers. So here the OTP, the Open Telecom platform, the OTP installs us the Erlang binaries into our application. Yes, install. So that's the installation process for Erlang. Once Erlang is successfully installed, we can run the Elixir web setup, which dynamically downloads the latest version of Elixir, which is 1.9.2 at this point in time. So let's install this one as well. Refer to Erlang, install. So now Elixir is installed, so we're done with this particular part. The next thing we need to do is we need to clone our repository. So I already have Git on the local machine. Git clone that repo. And inside the repo, the first thing we need to do is we run Elixir's mix command. Mix is basically the build and compilation tool for Elixir. We say mix deps.get. Oh, actually, we need to restart this thing. cdx mix deps get, which pulls all the dependencies. Yes, please. Which pulls all the dependencies from the internet. And once that's done, we run mix compile to actually generate all the artifacts. Click pause here for a second of the recording. So, and towards the end of the compilation process, we are back in our shell, and we have, so our mix compile process, if we re-trigger it, it has nothing in addition to do. So the next thing we can do is, because we will be running the interactive Elixir prompt, we can set an environment variable. And now, so this basically means we want to run the interactive shell in a command in an explicit window. And now with IEX-S mix, we now have a new window here. Select font. Let's increase the font size of this a little bit. Cascadia in size 16, for example. Now this is our interactive shell. Let's also, in addition, start Visual Studio Code in the current directory, because that helps us to see the data on which we're working. So inside the sample files folder, we have a bunch of different JSON files. And our goal is to transform these JSON files into a different representation, where we can see what all these things would be evaluated. So now we can go towards the evaluation. The first thing I can do is I alias, create a couple of aliases to save some typing, and let me log into Azure. So I'm essentially triggering a device login here locally. So I need to navigate to the device login page. of Azure. Oops, device login page of Azure. And I need to supply the device code from here. Yes, this is the account which I want to use against my subscription. The reason why we're logging in is some of these commands can talk to Azure to fetch context for already existing resources. So these resource functions basically run much better if we are signed in to the Azure portals and we don't see dummy test data. We set our subscription over here. And after the subscription, we create a deployment context in which we point to our subscription ID and to a particular resource group against which we want to do the deployment. And after all this pre-work, now finally the interesting part happens where we take an existing file and mangle it with the demo utility into a different form. So what you can see here in the shell, this basically, well, let's write this slightly different. So this pipe symbol, in case you haven't seen it before, the F#, people might sample files forward1.json. So essentially this pipe symbol here makes sure we pass in this one here as a first argument. And this call demo util transform 1.json essentially reads 1.json, uses the deployment context which I specified up here, which points to my subscription, and a dictionary containing, or a map in Elixir containing all the parameters. And finally, what I now can see in this picture is a result.json. So when I open these two files side by side, and this is now a little bit tricky given the resolution, what we now can see, let me make this a little bit smaller. What you now can see that, for example, this particular statement, which is an Azure Resource Manager statement. The angle brackets here specify an ARM statement, and the 3 inside, it means this is literally the 3 value, evaluates to the number 3 down here. The subscription, the call to the subscription function effectively ends up in an object which points to my subscription ID and a certain display name like Geuer-Work. Or you can see here with the deployment name, so we are having some parameters being passed in. So when we look, for example, here I have a deployment name, and because I didn't specify anything, the default value is some prefix. So when we have a look in the evaluated version, we can see that this prefix, where do we use the deployment name? For example, we use it here. The deployment name concatenates deployment name with some name. So down here we can see some pre is this one, and some name effectively was a representation of an array from over here. So if we, for example, say some name now equals Gaga, literally is a string, and we run the utility again, at that point in time, we have here in the evaluated version some pre-Gaga. For example, we can, let's change this to include some dashes between the two values. We concatenate a couple of dashes. And let's also supply a different value for the deployment name. So now we are basically saying the deployment name should be hello world. Now, in the evaluated version, we see the hello world being passed down. What's also funny is this template uses a custom function. So postgres.createODBC connection string is effectively a custom function which is defined down here, which does certain things. No, actually, it's here. This is the createODBC connection string function, and it concatenates a bunch of parameters into a longer string. So by calling this particular connection string, it gives me actually the literal value where we have all these things like our deployment names and so on inside the picture. This this little utility essentially contains, for all the string functions and logical functions which you have inside ARM, a complete, end-to-end implementation. So simply by saying, like, take a certain file, let's take a different one, let's take the automation file, and let's run this against, so automation is the second sample here. So are we having any problems? Okay, we're having problems because, for example, here, the parameter admin password is not properly set. So let's run this again, and let's say that the admin password maps to super secret 123. And when we now look over here, we have that secret down here. But that secret, for example, is also given down into a key vault. We have role assignments here. We have Postgres databases. And down here, we can see that inside the key vault, for example, we are setting a secret, and the actual content of the secret contains somewhere down here our super secret password. So that's all I have to say. If you like what you see, being able to quickly round trip between a fully parameterized and templated version on one side and having a live view into how all these values should, in theory at least, be evaluated by the Azure Resource Manager portal, please give me a quick shout out. I'd love your feedback. Bye-bye.